Electrochemistry exercise, a chemist heated a solid zinc chloride and until it became a molten. And the apparatus shown was then used to pass electricity through a molten zinc chloride using the inert electrode or the unreactive electrodes. A silver colored solid was formed at a negative electrode. Name the process of breaking down a substance using the electricity. What we call this. You can use your mic, you can use a screen annotation, you can use the chat. So we call that as electrolysis. And what actually happened here in this electrolysis, because we have a zinc ion and we have a chloride ion, zinc ions are positive ions, they are attracted towards the cathode. That's why at the negative, the shiny solid is formed. And chloride ions are attracted towards the anode. So as a result, it will produce a yellowish green gas, as chlorine is yellowish green. A Bunsen burner was used to heat zinc. Describe how a Bunsen burner is adjusted to give a very hot flame. So this usually what happen. Look, the idea is that for a Bunsen burner, we have air holes. What is the effect of the, like, this is the inlet for the gas and we have air holes here. What is the effect of these air holes? These air holes make sure that we have a plenty of oxygen so that when we are burning a gas, it will be a complete combustion. So that's how we adjusted the flame of a burner. Even the stoves which we are using for cooking in our home, that is also using the same concept that it is like changing the amount of the gas which enter or amount of oxygen which interact with the gas. So these air holes which are present in a Bunsen burner, what we should do if we want to heat or we want to supply heat energy, too much heat energy, we should keep these air hole open. Is it clear, this one?
Yes, sir, clear.
Then suggest and explain the expected observation at the positive electrode or anode. At anode, what
Bubbles
we,
of bubbles of pale green gas.
so you can mention bubbles or you can mention a yellowish green gas. But because they ask for observation, so you're not supposed to say like in terms of electrons, not about, you just have to mention what you will observe or what you will see. So when you mention you will observe yellowish green gas, yeah, that's I'm explaining a point. If a question is that suggest and explain, so the expected observation here in this one, you mentioned yellowish green gas, but what if the question is only state what is observed, then only you'll mention yellowish green. Here the question is state, suggest and explain, like reason for that. So chloride ions are negative ion attracted towards anode. As a result, it will form a chlorine gas. Here you have to explain as according to question. I'm talking in journal. If a question is about observation, don't try to write anything about loss or gain of electron. Just write what you will see. Suggest why iron electrodes are not used for this experiment. So iron is an inert metal or inert electrodes are there. That's why we don't use it. Iron can react. What difference would the chemist observe at the negative electrode if aqueous zinc chloride is used rather than molten zinc chloride? Like if we use a molten zinc chloride, the molten zinc chloride contains zinc ion and the chloride ions. But in aqueous zinc chloride, it contains zinc ion, it contains chloride ion, it contains hydrogen ion, and it contains hydroxide ion. So during electrolysis, if we do, chloride ion will move and zinc ion will move. But here what will happen?
Hydrogen will move as it's less reactive than zinc.
Yeah, so hydrogen will move. So there will be a hydrogen difference in the observation. So there will be, but difference in the observation. So again, what difference is there? You don't say hydrogen formed, you should mention bubbles. Because difference in observation. Whenever a question is about observation, don't mention the name of a substance. You're not, because by looking at a substance, you don't say in chemistry that this is a substance. So what we'll observe bubbles. And reason is that because hydrogen is less reactive than zinc or hydrogen move towards. So here bubbles, and here as it is less reactive than zinc, so it is extracted or moved towards. The next one, when electricity is used to break down a concentrated zinc chloride, chlorine produced at a positive electrode. Describe a test for chlorine. How we can test, how we can check that this gas given off is a chlorine. What is the test for a chlorine? So we use, no, lime water is for carbon dioxide. Chlorine is damp. For chlorine, it is a damp blue litmus. It bleaches or it removes the color. By using a damp blue litmus, you should mention first it turned red and then bleach. A bottle of a zinc chloride is labeled as corrosive. Chlorine is, it can bleach. It is a bleaching agent, but don't mention blue. Don't mention red. There's a reason for that. So whenever you mention it, you should mention starting with a red litmus, a blue litmus. So if we say it is a corrosive, what safety precaution we should take? So wear gloves or goggles. In question 3, a student investigated the gases formed during electrolysis of a dilute sulfuric acid. Using the apparatus shown, hydrogen and oxygen were produced. Complete the box to name the apparatus. So whenever both arrows you have to label what we call them as electrode. On the diagram, sketch how a sample of one of the gas can be collected. Like you have to just draw how a gas can be collected here, how we can collect one of the gas.
By putting inverted test tube.
Hmm. Filled with filled with electrolyte. Look, this one, how it can be done whenever we want. Sometimes they ask this question like how a gas sample of a gas should be collected here. And test for oxygen is a glowing splint. It will relight. That's correct. But what we usually do, we don't use a gas syringe here. Gas syringe is usually used whenever a chemical reaction, a gas is given off in a conical flask or in a test tube. Then we connect the test tube or a mouth of a test tube or a conical flask by a delivery tube, and then we connect a gas syringe. That is how gas syringe is connected. But during electrolysis, when a gas is given off, so what we usually do, we take a we take a test tube which is filled with electrolyte, and we invert it on this electrode. The moment we invert on both of these electrodes, what will happen? So some of the liquid will enter, like mix with the electrolyte, but because that is already electrolyte, so it won't make much difference. And remaining of it, the gas will occupy the space. Like as a gas is given off, so gas will be released and this will collect a gas here. So that is usually what we do. We fill the test tube completely with the electrolyte. So fill the test tube completely with an electrolyte and invert it on the electrode. So when this is inverted on the electrolyte, some of the electrolyte will run out from this test tube and the gas will occupy the space. So how much space is occupied here? That is the volume of the gas collected. No, oxygen support burning. So if we have a glowing splint, it will relight. The gas collected at a positive side turned lime water milky. Based on this observation, lime water milky, which is this gas, which turned a lime water milky, that is carbon dioxide. And remember one thing in exam, when you write, don't write these formulas. Right now, it's fine, you're writing a formula, but in exam, write as by carbon dioxide, sulfur dioxide. Don't try to write in short. And suggest how this was formed. So that's right, because what happened, the oxygen which was formed, yes, any drawing is pencil allowed. Even you can use a pen to, but it drawing and graphs or the like completing a graph, sketching a graph, all should be done with pencil. Axis you can mark later once you are sure that that nothing else will change. Then you can just label the axis with pen. So suggest how this gas is formed. The oxygen react with the electrode like we have inert electrodes. So carbon plus oxygen give off carbon dioxide. A solution of a dilute sulfuric acid was electrolyzed for 1 hour. Why the pH of a solution decreases during electrolysis? Like we are doing electrolysis for a very long time, and eventually what happened? The pH is decreasing. So why the pH is decreasing? Because the concentration of hydrogen ions or the concentration of sulfuric acid is increasing. Because what happened when we do electrolysis of the sulfuric acid which contain H plus ion, SO4, H plus and OH minus. So H plus ion move towards cathode, OH will move towards anode. So water is removed. As the water is removed, so solution become more concentrated. And as the solution become more concentrated, the pH of a solution, if it's an acidic solution, the pH will decrease, and if it's an alkaline solution, the pH will increase.